Hi, welcome back to Geometry. This is section 7.3, Proving Triangles Are Similar. So, in the previous sections, we learned that similar meant that all of the corresponding angles are congruent and all of the corresponding sides are proportional. You don't need to know all of them in order to prove that two triangles are similar. So our objective today is to use the AA similarity postulate and the SAS similarity theorem and the side-side-side similarity theorem to use similarity to find indirect measurements. It's essential that you understand you can show that two triangles are similar when you know the relationships between only two or three pairs of corresponding parts. So very much like when we were proving that triangles were congruent, how we had side, 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 angle, side, angle, 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 side, hypotenuse, leg. In this case, we're just proving that two triangles are similar. And much like we proved back when we were proving triangles congruent that you couldn't know just the angles, well, now you can. Because similar means that their sides are proportional. So if you know two angles, then you know the third angle are congruent, and so you could prove that they're similar. We'll explore those today. So the first thing you want to take note of in your note template is the angle-angle similarity postulate. So we'll refer to it as AA, similarity. Remember that little squiggle is a symbol for similarity, similar. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Not congruent, similar, right? That means that one's small and one's large. So in this example, angle S is congruent to angle M, and angle R is congruent to angle L. So therefore we have enough information to prove that these two triangles are similar using the AA similarity postulate. So let's use the AA similarity postulate. Don't forget what you learned back in chapter 1 about vertical angles, linear pair, complementary, supplementary, because that's all going to come back now. Are the two triangles similar? How do you know? So let's look at these two triangles. We know that angle R is congruent to angle V, and you might have forgotten about these, but here it is, the bow tie. Remember what those are called? Begins with the letter V. Those are vertical angles. Therefore, you know that triangle RSW is similar to triangle VSB. How do you know? Angle-angle similarity postulate. Let's take a look at this one. Are the two triangles similar? How do you know? Well, we know that angle J is 30 and angle L is 70. We know that angle R is 70 and angle Q is 85. You also know that all three angles of a triangle equal 180. So how much is angle K? 70 and 30 is 100. 180 minus 100. Angle K is 80. So you cannot prove that these two are similar because this one wouldn't be 30, it would be 25. And so, no, these triangles are not similar because you only know one angle is congruent. In order to use this postulate, you need to know two, angle-angle similarity. Then we have side-angle-side similarity. Now, this is just like side-angle-side congruence in the way that it's side, the included angle side. So, in this situation, the sides are not congruent, they are proportional. So, if an angle of one triangle is congruent to an angle of a second triangle, angle A to angle Q, and the sides that include the two angles, so it's got to be the ones that make these angles, are proportional, not congruent, but when you set them up, their measures come out to be equivalent ratios. You can cross multiply and you'll get the same product. Then the two triangles are similar. So because you know that AB over QR is equal to AC over QS and angle A is congruent to angle Q, then you have enough to prove that the two triangles are similar. And then we have side, side, side. Now, this is very much like side, side, side congruence, but they're not congruent to each other. They are proportional. That's the key difference with similarity. It's proportional, not congruent. The angles are all congruent, but the sides are proportional, meaning they'll all reduce to the same ratio. And when you cross multiply, when you use the cross product property, you'll get the same product. So if the corresponding sides of two triangles are proportional, that means all three pairs have to be proportional. Then the triangles are similar. So let's try a few of these. Verifying triangle similarity. Are the triangles similar? If so, write a similarity statement. Now, you have to be consistent. In this case, I am going to put all the measures of the smaller triangle on top. So these are going to be my top measures, and these are going to be my bottom measures of my ratio. Now, in order to compare them, I'm going to go from least to greatest. So, in my top, I'll do those in blue. In my top, I have the smallest side is 6, then the medium is 8, and then the largest is 10. In the bottom triangle, the smallest side is 9, the medium is 12, and the largest is 15. So if these are all proportional, if they're all equivalent, then these triangles are similar using side, 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 because that's what I have is all three sides. So you can do this a couple of different ways. You can cross multiply all of your proportions to see if they work out. You could do 9 times 8 and 6 times 12. We could do 12 times 10 and 15 times 8. So that's one way to do this, to cross multiply. However, you could do this another way. If all of the ratios reduce to the same, which it would be the scale factor, if they all reduce to the same ratio, then you can also say they're similar. They'd all be equivalent. So 6/9 reduces to 2/3. 8/12, 4 goes into 8 twice, 4 goes into 12 3 times. 10/15, 5 goes into 10 twice, 5 goes into 15 3 times. All these ratios reduce to 2/3. So our scale factor in this case would be 2 to 3. It's a 2/3 ratio. We want to write a similarity statement. That means we want to say triangle is similar to triangle. You have to put them in the right order, just like when we were writing congruent statements. So again, if I follow that order and go small, medium, large. So my smallest side here was ST, then the medium was TU, and the large was US. So I'm going to call this STU, because I went from S to T to U. Now I'm going to do the same thing here. I'm going to go small, medium, large. So I know I have to begin here at X, because I'm going to go small, X to V, medium, V to W, then along the large. So I'm going to call this XVW. So because I know that these two triangles are similar, now I also know that means angle S is congruent to angle X, angle T is congruent to angle V, angle U is congruent to angle W. So are these triangles similar? If so, write a similarity statement. Well, it's important that you recognize the two different triangles that you have in this picture. We have two triangles here. We have triangle, and you know from our work with overlapping triangles when we were doing congruence. I have this triangle, LKP, where L to K is 8 and K to P is 12. I don't know LP. Then I have this other triangle, the larger one, MKN. And M to K is 2 and 8. Because it's 2 and 8, it's 10. k to n is 12 and 3. 12 and 3 is 15. Now here's the thing. They overlapped here at angle K. So, are these triangles similar? If so, we're going to write a similarity statement. Well, I know that angle K is congruent to angle K by the reflexive property of congruence. So now I just have to show that the corresponding sides are proportional. So, smallest over smallest, largest over largest. So I'm going to go with the first triangle here, the red one, and I'm going to put those measures on top, 8 and 12. And now I want to put the corresponding measures on the bottom. So because 8 was the smallest in the red triangle, I'm going to match it to the smallest in the blue triangle. 8 over 10, is it equal to the larger side in the red triangle over the larger side in the blue? 15. And again, you can cross multiply here and say, do you get the same product? I'm going to get 120 is equal to 120. Or, again, I could use that same strategy where I reduce them both. And I could say 8 over 10, 2 goes into 8 4 times, 2 goes into 10 5 times. And then 12 over 15, 3 goes into 12 4 times, 3 goes into 15 5 times. So they reduce to 4/5. So my scale factor here is a ratio of 4 to 5. It's a 4/5 scale factor. So because they are similar, using side, angle, side, similarity, I need to write a similarity statement. So the similarity statement would be triangle. I'm going to call this one LKP. I'm going to go smallest to the longest. So I'm going to call it LKP. LKP. And now I'm going to match it to the other triangle. It's similar to triangle MKN. It matters what order you write these in. You have to match the corresponding angles. It's essential that you understand that sometimes you can use similar triangles to find lengths that cannot be measured easily using a ruler or other measuring devices. This is using indirect measure. So here's my example. Lance the alien landed in town at 4:30 p.m. last Tuesday. Lance was sent here to take a tree, but he needed to be sure it would fit in his ship. If his ship had 20 feet of storage space, did the tree fit? Lance is 5 feet tall, and his shadow is 8 feet long. At the same time of the day, now that's the important part of this. They love to use these kinds of questions on MCAS. When the sun is up, it's the same time of the day. Same means similar. The shadow is going to cast a similar angle. So at the same time of the day, a tree shadow is 32 feet long. How can Lance determine the height of the tree? Well, let's see. You don't know the height of the tree. But because it's the same time of the day, the sun is projecting the shadow for each of these. So what we really have here is Lance's height and his shadow. The tree's height, we don't know, but we know the tree's shadow. So you can write a proportion to solve for this. Because it's the same time of the day, these are going to form similar triangles. They're both standing up straight and tall, we're assuming. So, the height of Lance over length of Lance's shadow, 5 over 8, height over shadow, equals the height of the tree over the length of the shadow, which is 32 feet. Will this tree fit in the cargo space on his spaceship? So you want to cross multiply and divide. 8 times x is 8x. And 32 times 5 would give us 160. So you would divide by 8 to find that the tree is 20 feet tall. So it'll fit. Lance can take it back to outer space. We'll work more on this tomorrow in class. Be ready for the notes quiz.